Assalamu everyone, my name is Ali Haider and my group mate Ali Javed and we're representing our group project TileGen. It is supervised by Dr. Akbar Abid Kirdezi. TileGen is basically an e-commerce store application which provides you a facility to purchase tiles online instead of being physically present somewhere inspecting the tiles yourself. This facilitates, this streamlines the process of buying and purchasing tiles at any scale, be it a single tile or a collection of whole tiles for your whole home. We begin with ceramic tiles. We have different kinds of ceramic tiles. Here you can see different kinds of mosaic, ceramic tiles, and different porcelain tiles. You can add them to your cart. You can select the size of it you want. You can select the quantity of it, and you're gonna buy it. Once you click and add to cart, the item will be added to cart. Up next, we have this facility to show the tiles in 3D. We can show several different kind of tiles in three-dimensional space, which you can interact with as well. Let's suppose here, once we have ceramic blue floral tile. Here it is. You can interact with it to look at what kind of shape it has. It's a square tile, and this interaction is important so a user can look at, even decide its thickness as well. In next module we're going to discuss that. Then we have tile calculator basically help us to figure out how many tiles we need for our room, for number of walls, or if let's suppose we have a floor, it shows us how many we need for certain kind of area. It gonna divide it then with the measurements of a tile, and it figure out the number of tiles it needs. It also has a facility to have designable tiles and undesignable tiles. It basically means that if we have certain kind of a pattern in it, then how it will work. A simple example of it is that if we have tiles, then we're gonna have this square rectangle design of a marble inside of it. It leaves that calculation for it. Up next, we have generate tiles. This is basically the main AI module that we worked on. It begins with Stable Diffusion 3.5 Large Turbo. We're using that from stability.ai. It helps us to create an AI tile. Let's go with some prompt that we could use for our tiles that we could later have to later we can print it. Let's suppose we have blue ocean with ships. Once we have ships in it, it should be ceramic tile. Ceramic tiles. Other than that, we can add water waves. Let's take ceramic tiles at the front, so it has more bias rather than with respect to others. And let's generate it. If it's now regenerating, and it takes a bit long because it responds. 3.5 is a fairly large model. Ta-da! Here we have a tile. Now the next step is that we need to figure out how to convert this into a 3D printable form. This is a 2D form, and we need to figure out some way so that this could be in a 3D form, so we can actually have it printed for ourselves, so we can put it on our wall. So for that purpose, we're gonna use STL, and all of that stuff is happening in Python, and there was a bit lag of resources for us, so we need to use online free resources we have. So here comes this next part. We're gonna begin with the image and we're gonna convert it into STL. The thing is that we're gonna use this image, we're gonna create a grayscale of it, we're gonna convert it into a mesh, and then we're gonna deliver it to the user so he can have it printed. So first we're gonna install all the dependencies we have for this project, which is of pip. Now we're gonna have upload our file in here. I wanted to do that all behind the scenes, but turned out that there's this particular problem with JavaScript. JavaScript doesn't have that. What JavaScript can't do that much of a mathematical calculations, or you can say numerical computation. It lags that particular point which Python has edge on. So that is why now we're going to upload the image, we're going to convert it into grayscale, we're going to create its mesh, and then we're going to have it delivered to the user. Now this is something we're working on right now, and in next whole year we're deciding to have it proper. Now we're gonna convert it into the STL, and it would take some time. It's converting it. Mm, Even JavaScript usually takes about 20 minutes to get this done, and here with Python we're having it quite fast. So here we're using all of the STL numerical calculation. We're calculating the edges, we're calculating the faces of the tile. This is currently working for a single tile, but in a much longer scope, we're trying our best to get it done with maximum amount of tiles. Now it will download. While it is downloading, let me have it online. So once we get it done here, we're gonna show it over there. So the thing is, while it's happening, let me explain you how this works. So here it is. We have four edges, and these are normalized with respect to the tile. We're gonna have four vertices and two faces. We're gonna append these faces to our vertices array. With respect to each face, there would be vertices, front and back. On front side, we're gonna show our mesh. On the back side, we're gonna show the flat surface that would be attached towards the wall. So now here's the design. This is base thickness. Base thickness simply means the side that would be on the wall, the thickness, the amount of thickness that will stick on the wall. Now height map decides how much height a mesh requires, how much height a mesh will probably have. And now we're gonna have four edges as usual. These are the points above the flat surface, the mesh. We're gonna append these again. We're gonna create the model of it, and then we're gonna save the file. And once it's saved, we're gonna download it. And once it's downloaded, let me show you several others that we've created already. This is one of the examples that I've created previously during the evaluations in front of our CUI ComSets committees. So this is one of those. Here it is. This is one of the designs of ships. Here we have three ships, and here we have waves. And this was the tricky part. How should I figure out some way that we're gonna have a mesh on the other sides? Like, look over here, you can see all the triangles, and the bottom surface should be straight. Look over here, it's exactly straight. So we tried using STL, and we figured out that the simple way is that to create two different kind of tiles, one should be mesh and one should be the flat surface, and we were able to design a tile. This was whole scope of TileGen. Thank you so much and have a nice day.